I'm sharing on PPT. All are able to see it?
Yes, ma'am.
Okay. So what is the full form of laser? Light amplification by stimulated emission of radiation. Okay. So now we know that when we compare laser light with normal light, this laser light has got some certain unique features or characteristics. So what are those unique features? I think yesterday we were discussing about those features only. So coming to first feature, what is our first feature? Being directional. So first feature of a laser light is it is directional, and second one is it is monochromatic, and third one it is highly intense, and fourth one is coherence. I hope my voice is audible to all. Is it audible to all?
Yes, ma'am.
Yeah, okay. So these are the four characteristics of laser light which makes it completely different from normal light. So we are going to see what exactly is each characteristic. I think yesterday we have discussed about directionality, students. What we have discussed about directionality?
Laser light moves in only one direction.
Yes, good, very good. So laser light, if you take a light, suppose if I take normal light, that is nothing but tube light. Okay, if I switch on tube light in a room, then the room it gets illuminated by tube light. Why? Because tube light, what it will do, it will send all its beams of light in all possible directions. But whereas if we replace the tube light with laser light, and if we try to illuminate a room, it is not possible. Why? Because all the beams of laser light, they are going to go in single direction. So that's the room will not get illuminated. Right? So that property of going all beams of laser light in single direction is nothing but directionality. Okay, ma. So that is nothing but angular spreading. Angular spreading is really very, very small. All the beams, they are going to go and fall on small regions. So that's why we have laser pointers. So if you take laser pointers, so if you just put that pointer onto the wall, you'll be able to see just one spot. Those who have done experiment in the lab, they must have got idea about laser light. Okay, ma. So I think yesterday we have discussed about this. I think all these points we have taken, right, ma? So no need of discussing about directionality. So I'm going to second property. So what is our second property? Monochromatic. Okay. So what do you mean by monochromatic? When you call a light to be monochromatic. Students, what do you mean by being monochromatic? It means that actually monochromatic means exhibiting single wavelength. Single wavelength. Can you tell me what is the difference between white light and sodium light? Yes, students. What is the difference between white light and sodium light? Can anyone tell me what is the difference? What is the difference between white light and sodium light? Sodium, what is the color of sodium light? I'm talking about light. What is the color of sodium light? No, it is yellow in color. Sodium light, it is yellow in color. Of course, white light, it is white, but why it will appear white in color? Because it consists of different lights of different wavelengths. So here we merge different wavelengths of light. But whereas if we take sodium light, it appears yellow in color. It means that it has got single wavelength. Okay. So that's why it is appearing colored. So what do you mean by single wavelength? It means that it has got only one type of color. Whereas if we take white light is combination of different colors of different wavelengths. So if you say that laser light is monochromatic, it means that it exhibits single wavelength. Or how can we put it in other words? What you have to understand here is the line width of laser beam. So if we take this line width, this point is very, very important. Line width of laser beam is extremely narrow. So line width of laser beam is extremely narrow. And if you compare this laser light with normal light, what you can say here is, if you take conventional light means we are talking about normal light. In conventional light, what is that line width? It falls in 10 to the power of 6. Whereas if we take this laser light, it will be 10 to the power of 5. Okay. So this one you no need of taking mark. This generally we won't ask you. So just when we say that it is monochromatic, here we have to say that it exhibits single wavelength, and also line width of laser beam is extremely narrow. Okay, I hope you are able to understand. Yes. So shall we go for third characteristic? Now coming to third characteristic. highly intense. Okay, so when you will call a beam to be highly intense? What do you mean by light being highly intense? What, ma'am? Yes, hello? Yeah. So what do you mean by highly intense light? Suppose if you take laser light, what is the application of laser light, students? I think laser light, it is used for welding, soldering. Yes or not? Is it used for soldering or welding? I think it will be used for soldering and welding purpose. What do you mean by soldering? Where we can make two pieces join together. Welding also same thing. So it means that laser light has capability of melting certain materials. When we expose certain materials to laser light, then what happens to those materials? They will melt. Okay. So that is, it means that power of laser is very high. What do you mean by highly intense? Highly intense is power. Power of laser light is very high. Power is high. Okay, so that is what we mean by being intense. And why it has got this highly intense characteristic? Because of its directionality. Because of its directionality, laser light, it has got this property of being highly intense, because all the beams, they are going and falling at one region. It means that all the photons, they are getting concentrated in one region. It means that energies of all the photons, it is falling in one place. Okay, so that's the energy will be more, intensity will be more. So that's why we'll say that this laser light is highly intense. And here, if you want to know how many number of photons are coming out, this formula is very important. Now we are going to do problems based on this formula. Number of photons coming out from a laser per second per unit area, it is given by this formula. So just note down this formula. So what is N1? N1 represents how many number of photons are coming out from a laser per second per unit area. It is given by P by, what is there in the denominator? H mu pi r square. What is P? P is power of laser. Okay, and H is Planck's constant. Mu is what is the frequency of the laser beam. Pi is of course 3.14, and R is the radius. Suppose if I make that laser light fall onto the wall, so that spot it is covering, what is the radius of that spot will give you R value. Okay, so if you want to know for a particular laser beam how many photons are coming out, we are going to make use of this formula. But for that, we should know what is the power of that laser and what is the radius of the laser recorded on the screen. Okay, student, just make note down of this formula. So we are going to make use of this formula in solving numerical problems. Okay, so shall I change slide? Yes, students.
1 second, ma'am.
I hope you all are listening. All are attentive in the class. I think today I have 51 participants. I hope all participants, they are really listening to the class, not just logging and then doing your own work. Pay attention, because lasers, if you pay attention, it will be easy for you to understand and it will be easy for you to prepare for your exam also. So in 2 or 3 days, I'll finish this. Then after that, we are going to discuss question mark. Okay. So I'm changing slide, ma. All this formula we'll see later. Okay, no need of taking now. All this formula we'll discuss when I'm discussing numerical problems. Now coming to last and very important property of laser light is coherent. So what do you mean by being coherent? So being coherent means, see here, now I'm going to take two light waves. Suppose this is one light wave, okay, and this is another light wave. Both are going in this direction, and then I'll take one light wave going like this, okay, another light wave going like this, right, and then I'm going to take two more light waves going like this. Okay, now what we are doing, we are comparing two light waves. Now if you take this case one, this is my case one. In case one, both these light waves, first of all, they should travel in same direction. I think in all the three cases, those two light waves, of course, they are moving in the same direction. But in what way they are different from each other? If I take case one, in case one, if you see, this is crust and this is trough of a wave. I hope you people know what is crust and trough. Crust is position of maximum intensity. Trough is position of minimum intensity. And if position of one wave is exactly matching with position of another wave, or where you can say that crust of one wave is falling on crust of another wave, or trough of one wave is falling on trough of another wave, then in that case I'll say that these two waves, they are maintaining zero phase difference. They are maintaining zero phase difference. So if we take two waves and if their positions are matching and if they are traveling in the same direction, in that case we'll say that they are maintaining zero phase difference. But look at this case two. In case two, I think if you look at their positions, I think this is the difference of positions we have. Okay, throughout their propagation, they are maintaining certain distance. Okay, so in that case, we'll say that they are maintaining constant phase difference. So throughout the motion, these two waves, they are maintaining constant phase difference. But whereas coming to third case, in that case, if you say this is the crust of one wave, this is trough of another wave. So crust of one wave, it is falling on trough of another wave. Okay, so the positions are completely 180 degrees out of phase. So they are 180 degrees out of phase. So in this case, we'll say that they are out of phase. They are not in phase waves, but they are out of phase. Okay, so because their positions are complementary, completely opposite. Now, what do you mean by coherent? If you have two light waves like this, so if they maintain either zero phase difference or constant phase difference between them, then these two cases, they are, in that case, we'll say that these two light waves are coherent. So what do you mean by coherent? Coherent is nothing but when two light beams maintain. So when two light beams maintain either zero or constant phase difference between them. So if they maintain either zero or constant phase difference between them. Zero or constant phase difference between them. Then we call those two waves to be coherent. Constant phase difference. Okay, so what is this property of laser light? Laser light exhibits coherence property. So what do you mean by coherence property? Where if I take two different light beams of the same laser source, they are going to maintain either zero or constant phase difference between them. Okay, I hope you are able to understand, students. So just make note of these three figures so that you can understand what do you mean by having either zero or constant phase difference between them. Okay, so note down in your books. Finished copying? Shall I change slide?
1 second.
Okay. Okay, that
Complete, ma'am.
I'm changing. Okay, slide. Now what I'm going to do from next onwards, I'm going to discuss certain terms related to laser. So some important definitions we are going to discuss now. So as I have told you, so next process is discussing different definitions related to laser. So next you can just take side heading, basic definitions related to laser. And you all should get familiar with these definitions. Then only you will have idea about working of any type of lasers. So basic definitions related to laser. In the first definition is about absorption. What is absorption? Okay, so just look at the figure which is given here and tell me what is the process of absorption. Yes, students. So first definition related to laser light is absorption. So I have given here two figures. This is first and this is second figure. This is during absorption. This is after absorption. So look at these figures and tell me what is the phenomena of absorption. Yes, I'm waiting for your answer. Yes, I'm waiting for your answer, ma. What is absorption? Okay, now see here. Now coming to absorption, I'm again drawing this figure. Now first what I'll do, I'll take two energy levels. Okay, what I'm doing, I'm taking two energy levels. Let us call those energy levels as E1 and E2. I have taken two energy levels and I'm calling those two energy levels as E1 and E2. What is E1? E1 is ground state. E1 is ground state. And what is E2? E2 is excited state. So E2 is excited state. So E1 is ground state and E2 is excited state. Now, under normal condition means when we are not supplying any energy, where will be our electron or atom? It will be present in the ground state when I have not supplied any energy. Okay, so when we are not supplying any energy, all the atoms or all the electrons that are present in the material, they'll be present in ground state. Now, what I am doing to this electron or atom, I'll supply energy. What type of energy I'm supplying? I'm supplying a photon. Here, what I'm doing, I'm making a photon to fall on this electron or atom. And what is the energy of this photon? Energy of this photon, energy it is given as h nu, and energy of photon, it should be equal to difference of energy between E1 and E2. So if I take a photon whose energy is equal to h nu is equal to E2 minus E1, if I make this photon to fall on this electron, then what happens to this electron or atom? There will be transfer of energy from photon to this electron. So this electron, it is going to gain energy from this photon. And how much energy it is going to gain? Energy which is equal to E2 minus E1. Okay. Then what happens to this electron? After it takes energy, it will jump to higher state. So it will jump to higher state. So when it jumps to higher state, then what happens after absorption? Now where is our electron now? Because now electron is supplied with energy. Now electron, it will go to higher excited state. So it will be present here. So this is after absorption. Is after absorption, and this is during the process of absorption, or you can also say that it is before absorption. So what is absorption phenomena? So absorption is nothing but, first I'm considering two active energy levels, E1 and E2, where we are saying that E1 is ground state and E2 is excited state. And under normal condition, where are the atoms or electrons present? They will be present in ground state. Now what I'm doing with this atom or electron, I'm supplying energy, and that energy I'm taking in the form of a photon. And what should be the energy of photon? It should be equal to E2 minus E1. If it is not E2 minus E1, if it is some other energy, then this electron, it may not go to E2. it will go to some other energy level. If I want to make this electron go to E2, then I have to select a photon whose energy is equal to E2 minus E1. Then once this photon goes and falls on this atom in ground state, what this atom or electron will do, it will absorb energy from that photon and it will get excited. Where it will get excited, it will go to higher state E2. So this phenomenon of excitation of an electron or atom from ground state to higher state by supplying energy is nothing but absorption. Okay, students, I hope you are able to understand. Yes, are you
Yes,
able to
ma'am.
understand? Okay. I think
Yes,
down
ma'am.
definition is given. When photon is supplied, atoms in the ground state absorb energy and they get excited to E2. So this phenomenon is called as absorption. So take this figure and just write this last sentence in your books. Please maintain notes, all of you. Okay, so most of the this module days will have definitions, and if you are thorough with those definitions, then this topic will be easy for you to understand. Okay, so if you are done writing, then I'll go to next slide. Okay, ma'am. So finished? Shall I change slide?
No, no.
1 minute, ma'am.
Okay, then copy it down. Take all these definitions. I'm telling you, they're simple, but if you write it in your notes, so it will be easy for you to prepare for your exam. If you have finished, just let me know. Then we'll go for next definition. Over, ma?
Yes, ma'am.
Okay. Okay, okay. So we'll go for next definition. Now you just look at the slide and tell me what is our next definition. So what is our next? Yeah. So our next definition is spontaneous emission. Okay. So next definition is our spontaneous emission. One second. This is our second definition, spontaneous emission. Okay. Now again look at this figure. Okay, so look at those figures and you try to understand what is spontaneous emission. Now this is the initial state, this is the final state. Okay. Now, but before this, you people should know one more definition. The definition is lifetime. All of you note down in your books this definition. So what is lifetime? This is lifetime. What is lifetime of an energy level? So it is defined as duration of time. All of you take this definition. Ma? So duration of time spent by an atom or electron in an energy level. Duration of time spent by an atom in an energy level is nothing but lifetime of an energy level. All of you make note down this because after this we'll be making use of this term lifetime everywhere. Okay, so if I take one energy level, every energy level will have its lifetime, and when I say lifetime, it means that time for which an atom or electron stays in that energy level is nothing but lifetime. Okay. So first you people take this definition, then we'll try to understand what is this phenomenon of spontaneous emission. Okay. Okay, so now all of you listen here, ma. Now, see, look at this point. Again, we are taking those two energy states, E1 and E2, right? Now, just now we have taken definition absorption. So after absorption, where is our atom? Atom, it will be there in excited state. Okay. So this particular figure is after absorption, after the phenomena of absorption. So after the phenomena of absorption, where is our atom now? Atom, it will be there in excited state. Atom or electron in excited state. What is absorption? Just now we have taken. First atom, it will be in the ground state. And if we supply energy, which is equal to E2 minus E1, then what happens to that atom or electron? It will absorb that energy and it will go to higher state. So that is nothing but excitation of an electron or atom from ground state to excited state. Okay. Now, but once your atom goes to excited state, for how long it stays in that excited state? See, now after absorption, what happened to this atom? It has gone to higher excited state. Okay. For how long it will stay there? Forever will it stay with that energy? No. So every energy level will have its lifetime. What you have to understand here is every energy level, it will have lifetime. After lifetime of an energy level, what happens to this atom in the excited state? This atom, it will lose its energy and it will come down to ground state. So after lifetime, what happens to this atom, this excited atom? It will get de-excited to ground state. But because it is coming from higher state to lower state, it will release energy. In order to make an atom go from lower state to higher state, I need to supply energy. But when an atom comes down from higher state to lower state, then what it will do? It will release energy. And that energy, it comes out in the form of a photon. So again, as you can see here, there is a release of energy in the form of photon. And what is the energy of that photon? Again, it is equal to h nu, which is equal to E2 minus E1. And this phenomena, it is called as spontaneous emission. So what is emission? Emission is de-excitation of an atom or electron from higher state to lower state. Excitation or absorption means where atom goes from lower state to higher state. Okay. So what you have to understand, and spontaneous. Why we are using this term spontaneous? Because in order to push this excited atom down, I don't need to supply energy. This atom or electron, it is coming down on its own without pushing it down. And when it is coming down, after its lifetime. So the spontaneous emission takes place only after lifetime of an energy level. That you people have to understand. Okay, so what is spontaneous emission? How we have to put it? We have to say that once an atom gets excited to higher state after absorption, it will stay in that energy state for its lifetime. And after its lifetime, what happens to this particular atom? It will release energy and it will come down to ground state. And how much energy it will release? Again, it will release energy which is in the form of photon. And what is the energy of photon? Again, it is equal to E2 minus E1. And one thing what you people have to understand here is when one atom comes down, one photon is emitted. And when two, suppose I have taken two, here I am drawing it again. Suppose this is E1 and this is E2. Suppose there are some 10 number of atoms. Suppose these are all excited atoms after absorption. Now when one atom comes down, one photon is released. One photon is released. When one more atom comes down, one more photon is released. Then again one more photon. So like that, for each emission, spontaneous emission, we are going to get one photon. So when many number of atoms are coming down, we'll have many photons. But if you look at all those photons, these photons, when they are traveling, when they are moving, what you will observe here is their positions won't match. So that's why we'll say that they are out of phase with each other. And these photons, they are going to have different wavelengths. So what type of radiation will get out of this spontaneous emission? So what you have to understand here is radiation which is coming out during spontaneous emission is incoherent, okay, polychromatic, and also here what you have to understand here is it is less intense. So the spontaneous emission, it is going to give us light radiation. But what type of light radiation? So it will give us, so here it is going to give us incoherent light, incoherent, okay, non-directional, and then less intense, as well as polychromatic radiation. Polychromatic means it has got many wavelengths. Polychromatic light radiation. So out of spontaneous emission, we are going to get such type of light radiation. This is what you have to understand. Okay, so whatever photons are released during spontaneous emission, all those photons together, they are going to give us which light, which is incoherent. Incoherent means where they are out of phase with each other. Non-directional means all those photons, they won't go in single direction, but they go in different directions. Less intense means because per emission, I'm going to get only single photon. Okay, so number of photons released are less because per emission we are getting only single photon. So that's why we'll say that less intense. When we'll call light to be more intense when you are able to get a high number of photons. But here we are getting few number of photons during the excitation. So that's why it will be less intense. And why polychromatic? Each photon, it will be traveling with different wavelengths. So they have different wavelengths. That's why we'll say that it will give rise to polychromatic light radiation. So this is our spontaneous emission. I hope you people are clear. Any doubts? Any doubts, students? If you have any doubts, you can ask me. Otherwise, just you take this definition and figure in your notes. Then we'll go for next definition. Okay, ma'am? Are you ready? Have you copied it?
Yes, ma'am.
So shall I change slide? I'm changing slide then.
Okay, ma'am.
Okay, ma. So I'm going for next definition. Okay. So what is our third definition?
Stimulated emission.
Stimulated emission. Okay. So look at this figure and tell me what is stimulated emission. So look at this figure. So look at this figure, and now because already we have discussed about absorption and spontaneous emission, now tell me what is stimulated emission. So all of you look at this figure. Let me see who will give me answer. My students, see this figure and tell me what is stimulated emission. I think from the name itself also you can make out what is stimulated emission. This is also emission. Emission means what? అరే అబ్జార్ప్షన్ అంటే ఏంట్రా ఎక్సైటేషన్ డి ఎక్సైటేషన్
Excitation.
excitation, right? Absorption means excitation, going from lower energy to higher energy. For that we need energy or not? We need energy, right? For excitation. Okay. Then after that we have emission. Emission ante enti? De-excitation. De-excitation means coming from higher energy level to lower energy level. Our de-excitation, we have two types. Previous one, what we called it as spontaneous emission. And what is this one? Stimulated emission. What is spontaneous emission? For the de-excitation, we don't need energy. That atom or electron, it will come down on its own. But in this case, it is stimulated. Stimulated ante by force, I have to make it come down. Okay. So just look at this figure. Again, the same story. After absorption, where is our atom? Atom, it is in the excited state. Now, I want to make this atom come down before its lifetime. This you have to understand, students. See here, look at this point. An atom which is there in the excited state, it is made to de-excite to ground state before its lifetime. Anyway, after its lifetime, it will come down. But we have to make it come down before its lifetime. So for that, what I have to do, I have to push it down. And in order to push it down, again, what I'm doing, look at this first figure. Again, I'm making use of a photon. Again, this photon energy will be h nu, which is equal to E2 minus E1. Again, I'm taking help of photon in order to push this atom down. So if I make a photon whose energy is equal, and that energy again, it should be E2 minus E1. It should not be some other thing, some E3 minus E2 or E4 minus E3. Again, this photon which is pushing this atom down before its lifetime, its energy should be equal to E2 minus E1. Then what happens to this atom? When this photon goes and falls on it, this atom, it will push it down. And when it pushes down, when this atom in the excited state comes down, how many photons are emitted? Now, as you can see, there are two photons emitted. This is first photon, this is second photon. What is first photon? My first photon is this incident photon, which is pushing it down. And second one is emitted photon. This emitted photon is nothing but photon because of de-excitation. What is de-excitation? We know that when an atom de-excites from higher state to lower state, it releases energy, and that energy comes out in the form of photon. So the second photon, it is because of de-excitation from higher state to lower state, whereas first photon is a stimulus energy which is pushing it down before its lifetime. So per emission, how many photons are emitted? Two photons. Okay, then if two atoms come down, four photons. So you'll observe that number of photons emitted during stimulated emission, they are more in number, and they will be in phase with each other. All these photons will be in phase with each other. They will have same wavelength, and they will be moving in the same direction. So that's why what type of light we'll get because of stimulated emission? We are going to get directional. Okay, light which is directional, and then which is monochromatic because all of them have single wavelength, so it is monochromatic. So directional, monochromatic, highly intense, so it has to be highly intense. And then what is one more property? To coherent light radiation. So we are going to get coherent light from stimulated emission. I think these are all properties of laser light. These are all properties of laser light. Which phenomena will give us laser? What is the phenomena which is going to give us laser light? Stimulated emission. I think we have seen in that abbreviation laser. Somewhere we have come across stimulated emission. Okay, so main phenomena which is giving us laser light is stimulated emission, but in order to get stimulated emission, I need to take help of previous two processes which we have discussed. What are those two previous processes? One is absorption and second one is spontaneous emission. So that we are going to understand when I discuss about laser system, where we'll see how absorption and stimulated emission are going to help us to make this phenomena stimulated emission. Okay, students, any doubts here? If you have any doubts, you can ask me. Otherwise, you just copy this in your notes. Okay, so just I'll give you 1 minute, copy this, then we'll go for next question. I hope you people are able to understand. So shall I change slide? Ma, shall I change slide or you're copying? ఏం చెప్పరేంద్రా అయిపోయిందా ఓకే వెయిట్ ఆర్ చేంజ్
Ma'am, 2 minutes.
okay okay someone is writing down so just wait for 1 minute then I'll change slide. Who is that singing? Huh? Isha, you're the one singing? I hope all have log in with your roll number, right? Otherwise, I'm telling you, it will be difficult for us to give you attendance. Later, don't tell that I was present on the day I was not given attendance. Okay? Now, after this, I'll give you one tabular column. This tabular column is very important now. All of you note down this tabular column in your notes. Okay, and you get break also so that we can continue for next hour. So this tabular column is going to help you understand better about spontaneous and stimulated emission. If possible, you try to copy this table in your notes. See here, what we are doing. See, generally question will be asked like compare spontaneous and stimulated emission. So these points will help you to understand them better. So here I am discussing about spontaneous emission. Here we have stimulated emission. So what is the first point here we have in spontaneous emission? This emission, it takes place without the help of stimulus energy. So it will take place without the help of stimulus energy. Stimulus energy means I don't have to supply any energy to push it down, because this emission, it is taking place after lifetime. So on its own, that atom, it is going to come down. But whereas if we go for this stimulated emission, here we need the help of stimulus energy. Okay. And what type of radiation we'll get because of spontaneous emission? Here we are going to get polychromatic, and here we are getting monochromatic. And per emission, how many photons are emitted? 1 photon. Here 2 photons are emitted. And here, because number of photons emitted during stimulated emission are more in number, so that's why it is highly intense. Here it is less intense. It is less directional and more spreading will be there. It is highly directional, less spreading, and here incoherent and coherent emission. And the spontaneous emission, it was proposed or postulated by scientist Bohr. But whereas stimulated emission, it was given by scientist Einstein. And examples are, if you want to take spontaneous emission takes place in normal light. Okay, so here in the lab, when you come next time lab, you will find the mercury bulb as well as sodium vapor lamp in our dark room. So these two sources, we can take them as spontaneous emission. Whereas if you take laser light coming from ruby laser or helium laser, that comes under example of stimulated emission. So just quickly note down this tabular column. It will help you to understand these two phenomena better. Okay, I'll give you 2 minutes. Just copy this tabular column. Are you done? Shall I change slide? You're copying? Voice సరిగ్గా రావట్లేదు రా మీది. Still you are copying, ma?
Ma'am, 1 minute.
Okay, I'll give you 1 minute. Copy.
మ్యామ్ 2 photons ఎలా ఎమిట్ అవుతుందో చెప్తారు ఒకసారి.
2 photons ఎలా అంటే what is stimulated emission? I'm drawing the figure again. మనము స్టిమ్యులేటెడ్ ఎమిషన్ లో ఫస్ట్ మన ఆటమ్ ఎక్కడ ఉంటుంది, హైయర్ స్టేట్ లో ఉంటుంది కదా. సో ఇప్పుడు నా వాట్ ఈస్ స్టిమ్యులేటెడ్ ఎమిషన్? స్టిమ్యులేటింగ్ మీన్స్ I have to force this atom to come down before its lifetime. After lifetime అది అలాగో కిందికి వచ్చేస్తుంది, కానీ I have to make it come down before its lifetime. దాన్ని పుష్ చేయాలి కాబట్టి నేను ఏం చేస్తాను, దాన్ని పుష్ చేయడానికి నేను ఎనర్జీ సప్లై చేస్తాను. ఆ ఎనర్జీని నేను ఏం తీసుకుంటున్నాను? ఫోటాన్. ఓకే, ఈ photon when it goes and falls on this particular atom, what it will do, it will make it come down. And what should be the energy of this photon? This energy of photon again it should be equal to E2 minus C1. So if photon when it goes and falls on this, okay, then what happens to this? It will come down. Okay, now what will happen to this instant photon? It is present, right? Even though it has given its energy, but it is present. So that photon, this is our stimulus photon. What is meant by stimulus photon? Photon which is making it come down, okay, forcing it to come down. This is this photon. This is our first photon. Okay, and second photon is, we know that when an atom or electron loses energy, when it comes down again it will release energy in the form of photon. Okay, so one more photon comes because of de-excitation from E2 to E1. Okay, so this is because of de-excitation from E2 to E1. So this is our second photon, and first photon is this photon which is making it come down. Okay, so you may get doubt if whatever photon I'm giving, if it is coming down, how you will say that it is going to give us coherent light. So this phenomena you will understand when I discuss about lasing action. A lasing action lo meeku ee 2 photons ela build up avutundi, manaki number of photons anedi ela increase avutudo, you will have clear idea when I take lasing action. For the time being, what we have to understand here is, because in order to make this atom come down, I have to make use of one photon. So this is what, after it makes it come down, it will also come out, and apart from that, when this atom goes down, it is going to release its energy in the form of second photon. So that's why we are saying that there are 2 photons released per emission. I hope it is clear, Krisha. It is clear,
Yes, ma'am.
Okay, so shall I change slide?
Yes, ma'am.
Okay. Now coming to next topic, metastable state. Okay, so what is metastable state? Now just all of you listen here, ma. See, one by one, whatever definitions I am taking, they are very important, so you should know about these definitions. Now here, what is the process which will give us laser light? What is the main process which is going to give us laser light? Let's now have discussed. What is the main process which will give us laser light? Spontaneous, absorption, or stimulated?
Stimulated.
Okay, good. Now see here, in generally if you take any material, ఇప్పుడు మనం ఏం చేస్తాం, ఇక్కడ అబ్జార్ప్షన్ అయినా స్పాంటేనియస్ అయినా స్టిమ్యులేటెడ్ అయినా అర్థం చేసుకోవడానికి జస్ట్ we have taken 2 simple energy states. In that we said that E1 is ground state, E2 is excited state. But will we have only one excited state? Generally, if you take any material, will not have only one excited states, but will have many excited states. So there will be many excited states. So we'll call them as E3, E4, E5, and then E6, like that. You may have many excited states. So these are all excited states. Okay. So these are all excited states, different excited states. So if you take any material, in that material you will have one ground state, okay, and then you will have many excited states. Now each excited state will have one lifetime. Each excited state will have one lifetime. Okay, and what is the lifetime of ground state? We'll say that ground state lifetime is unlimited. Why we are saying it is unlimited? Because first, when atoms are present in the ground state, for how long they'll stay in ground state? Suppose I'm not supplying energy, any outside energy, then what will happen? I think these atoms they'll stay in ground state forever. Will you agree with me, Emma? If I don't supply any external energy, atoms which are present in the ground state, will they go up? If I don't supply energy, will they go up? No. Okay. So can I say that if I don't supply energy, they'll staying even forever? So that's why we'll say that it has got unlimited lifetime. Unlimited means there is no limit to its lifetime as long as we don't supply any energy. Okay, now coming to these excited state, you will observe that each excited state it will have one lifetime. And generally lifetime value, if you see some examples here we have given. So here one energy level lifetime is 10 to the power of minus 3 seconds. So it is very short time, students. And another energy level lifetime is 10 to the power of minus 7 seconds. Okay, so different energy levels will have different lifetimes. So now I'm not thinking about ground state. I'm just thinking about different excited state. So as I'm telling you, different excited state will have different lifetime. Of all these excited states, there will exist one excited state whose lifetime will be more compared to other excited state. This excited state lifetime is more. So the excited state whose lifetime is more, that excited state it is called metastable state. Okay, what is metastable state? Metastable state is the excited state which has got long lifetime. Now here, if you look at this figure, this is our ground state E1. Okay, this is one excited state E2, and this is second excited state E3. And what is the lifetime of E3? 10 to the power of minus 7 seconds. What is the lifetime of E2? 10 to the power of minus 3 seconds. Which one is more? Minus 3 or minus 7? Which is more? Which value is more? 10 to the power of
Minus
minus
3.
because it is in minus, so that's why this value will be more. So this energy level has got more lifetime, so that's why I'll say that this E2 is metastable state. So for don't just look at this process you'll understand when I go for next topics, but for the timing what you have to understand here is of all the excited state there will be one excited state whose lifetime is more, and that excited state it is called metastable state. Now tell me, in metastable state atoms will stay for more time or less time compared to other excited states? They'll
More
stay
time.
for more time. Why? Because we said that what is lifetime time for which an atom exists in that particular energy state. Because lifetime is more, so it will try to stay for more time in that excited state. I hope it is clear to everyone what is metastable state. So what is the definition? What you have to say is metastable state is excited state which has got long lifetime. Okay. So that is what we have taken. Just 1 second, ma. Yeah, students, are you able to hear me now? So you got idea about metastable state? Okay. So shall I go for next definition? You're copying?
Yes, ma'am.
Okay, copy it fast. Finished, Shuma? Some changing slide, students. Okay. And one more thing, I said that it has got long lifetime. You people copy this also. No? This is important. You may get in quiz. Forget about this figure. This is metastable state. Just now we have discussed. I want you people to copy this part. See here. This part. This part you people copy. So you people are familiar with Heisenberg's uncertainty principle? Heisenberg's uncertainty principle. Heisenberg's. What Heisenberg's uncertainty principle? Can anyone tell me what is this uncertainty principle? Yes, what is this Heisenberg's uncertainty principle? According to Heisenberg's uncertainty principle, it is impossible to specify precisely and accurately values of values of two members of a particular pair. So in this case, I think you people must have seen this expression as Heisenberg's uncertainty principle, delta x, delta p. Am I correct, student? Greater than or equal to h by 4 pi. Juice untar kadamma. Heisenberg's uncertainty. What is delta x? Delta x is position. Okay, and delta p is momentum, position and momentum. Alage, there are different pairs of variables. Here I have taken delta E and delta T. This is statement of, expression for Heisenberg's uncertainty principle. So what is delta E? Delta E is width of an energy level. Delta T is lifetime of electrons or atoms present in that energy level. Now, if I look at this expression, we'll observe that delta T is inversely proportional to energy level width. And we know that for metastable state, lifetime is more. So it has got long lifetime. So it means that its energy level width is small. So this statement is very important. So long lifetime of metastable state is because of narrow energy level width. Because its energy level width is small, so that's why its lifetime is more. So this part you people write down in your notes. Sometimes in quiz question or somewhere they'll ask you. Okay, part of Viva also they may ask you this question. So according to Heisenberg's uncertainty principle, lifetime is inversely proportional to energy level width. And we know that metastable state has got long lifetime. It means that its energy level width is small. And because of this small energy level width, its lifetime is more. Just copy this part in your notes. No need of taking this, already we have discussed. Just take this part. Okay, students. If you have any doubts, you can ask me. Copied? But whatever question you are selecting, you have to write here. Now you got some ideas. You understand how to do it? Exam is 45 pages. So I'm changing slide now. I hope you people have copied it. Okay.
Yes, ma'am.
Okay. Follow the question bank, students. Follow the question bank. See all the questions that will be looked at by the exam. Okay, now. Shall we start the class now? Now, next is population. So, next definition is population. So, population of what? Population of an energy level. So, this definition we are taking. So, population of an energy state. Okay. So, how you will define population of an energy state and what is the notation for this population? Generally, it is denoted by capital N. So what is capital N? Capital N defines population of an energy state and how it is defined. How many number of electrons or atoms are present per unit volume of an energy level is nothing but population of that energy state. So as I told you, suppose here I have one ground state E1, M1, and then I have two excited state E2 and one more excited state is E3. Suppose here I have only two number of atoms and here suppose I have six number of atoms. Okay, and here I have just one atom. Now suppose population of E1 I am representing it by N1, population of E2 I am representing it by N2, and population of E3 I am representing by N3. Now tell me which one is more? Which one is more? Obviously N2 is more, right? So population of which energy state is more? Population of E2 is more. So what is population? Having more number or how many number of atoms are present per unit volume of an energy level is nothing but population of that energy level. And this formula is very, very important. So this formula it comes from Boltzmann's distribution law. So this population comes from Boltzmann's distribution law. So according to Boltzmann's distribution law, what is the expression for population? So here this is population N in energy state E. So this is population N in energy state E. So what is the expression for population according to Boltzmann's distribution law? N is equal to N naught exponential minus E by T. What is K here? K is Boltzmann constant. And what is the value of Boltzmann's constant? What is the value of Boltzmann's constant?
10 to the power of
1 point. So what is the value of Boltzmann constant? K value it is equal to 1.38. 1.38 into 10 power of minus 23 joule per Kelvin. This is the value of Boltzmann constant. Okay. So what is N? N is population of energy state E. Okay. And how it is given? N naught into exponential minus E by KT. What is N naught? N naught is population of ground state. N naught is population of ground state. K is Boltzmann constant. T is temperature. And this is very, very important, students. See here. Generally, if we don't supply any energy, population of ground state will be maximum. And if you look at this particular equation, how N and E are related, they are directly related or inversely related? N and E, how they are related, how they are proportional, whether directly proportional or inversely proportional, because here I have exponential of minus. So that's why these both are inversely proportional. It means that as energy level increases, what happens to population decreases. So it means that as energy of excited state keeps on increasing, what happens to its population? It will decrease. So what you have to understand here is population, it decreases exponentially as energy state increases. This is very important. So generally, if we don't supply energy, population it will be maximum in ground state. As energy level increases, what happens to population? Population will decrease. So this is very important point. So note down in your notes this definition. Okay, students. Finished? Shall I change slide?
Yes, ma'am.
Okay, then we'll go for next definition. Yeah. Population inversion. So look at this figure and tell me what is population inversion. What is population inversion? Just now we have taken definition of population, right? What is population inversion? And other name of population inversion is, it is also called inverted population. So it is also called inverted population. Inverted population. Now, see here, generally under normal circumstances, normal and when I don't supply any energy, generally population of, see here, under normal condition, what you will observe here is population of higher energy level will be more or lower energy level will be more. Under normal state, whose population will be more? Lower state or higher state?
Higher state.
Lower state population will be more than
Yes. Right.
higher state, right? Okay. But by some means, if I am able to make population of higher state, okay, if you are able to make population of higher state more than lower state, if you are able to make population of higher state more than lower state, then that condition it is called as population inversion. So what is population inversion? Generally, when we don't supply any energy, lower state population will be more than higher state. But if we are able to make population of higher state more than lower state, then that condition it is called as population inversion. Now see here, this is normal population. Now here, if you just look here, this is E1 and this is E2. I have taken two energy levels, E1 and E2. Let us suppose that N1 is population of E1 and N2 is population of E2. And here we are saying that N1 is greater than N2. This is the case under normal circumstances. Normal circumstances is when I am not supplying any energy. But if I supply energy to all these atoms in ground state, what happens to these atoms? They'll absorb that energy and they'll get excited to higher state. Now in this case, whose population is more? Suppose again if it is E1 and if this is E2 and if this is N1 and if this is N2, I think when I have supplied energy, what happened now? N2 population has become more than N1. It means that energy higher state population, we are able to make it more than lower state, and this condition it is called as population inversion. And one thing what you have to understand here is population, in order to achieve population inversion, we need to supply external energy. So in order to achieve population inversion, we need to supply external energy. Under normal condition, it is not possible to achieve population inversion. Is it clear, students, what is population inversion? Yes. Any doubts? Any doubts? So what is the definition you will take for population inversion? You have tried that under normal state. Lower state population is more than higher state, but by some means, if you are able to make population of higher state more than lower state, that condition is called population inversion. So you take these two figures in order to understand it. Okay, so if you take it, then we'll go for next definition. So two more definitions are there. After those definitions, what we'll do, we are going to discuss about a laser system. First, we'll see what is the normal block diagram of a laser system. Then we are going to discuss two types of lasers, UV and helium laser. So mostly by Monday, I'm going to finish my syllabus. I think according to your schedule, from Thursday, you have your mid exams, right? Ma. Okay, so we'll take 2 days for discussion of question mark. Okay, problems from your side, and by tomorrow evening I'll try to give you both the second module as well as third module notes. Okay, ma. Then 2 days will take to discuss question mark. Okay. So if you are done with this population inversion, tell me. We'll try to finish at least definitions today so that we can discuss laser systems tomorrow. Finished? Have you taken this?
Yes, ma'am.
Yeah, see, ma, this figure why I'm taking here is in order to understand how population inversion is achieved. Now just have glance at this figure and you try to understand. See here, what I have done, I have taken three energy level system. First, all of you listen here carefully. I have taken a three energy level system. What do you mean by three energy level system? Where there are three active energy levels. How many energy levels? There are three active energy levels. So here we have three active energy levels. Can you tell me what are those three active energy levels? E1, okay, E2, and then E3. So on y-axis, let us suppose that I am taking energy. So E1, E2, and E3. Under normal condition, I think E1 energy, ground state energy will be less than first excited state E2, and first excited energy will be less than second excited state E2. So what is E1? E1 is ground state. E2 is first excited state. And E3 is second excited state. So there are two excited states and one ground state. And on the y-axis, we are taking N. N is population. So N represents population. Okay. And what is N1? N1 is population of E1. N2 is population of E2. N3 is population of E3. What is population? How many number of atoms or electrons present per unit volume is population. And of course, under normal condition, E1 is less than E2, less than E3. Also, population of ground state will be greater than first excited state, which is greater than third excited state, because we have taken one condition. As energy level increases, what happens to population? Population decreases exponentially. As I think I told you when I have taken a population concept. So as energy level increases, what happens to population? Population decreases exponentially. This point you have to understand. So this first figure is under normal condition. Normal condition means when we are not supplying any energy. When we don't supply energy, whose population will be more? Ground state population will be more. And as energy level increases, what happens to population? Population will decrease. So that's why we are showing this lesser line. This line, it is to show population. Okay, but when you have such an energy state and three energy levels, if I supply energy, okay, before this, what you have to understand here is you have taken this, whatever I have written here, just write in your notes. And now what I am saying here is, of course, E1 is ground state, right? E1 is ground state, and we know that ground state energy, this ground state, it will have unlimited lifetime. Unlimited lifetime means its lifetime will be more as long as we don't supply any energy. So as long as we don't supply any energy, it will have unlimited lifetime. Okay, now there are two excited states. E2 and E3. Let us suppose that E2 is metastable state. Let us suppose that E2 is metastable state and E3 is higher excited state. So let us suppose that E3 is higher excited state. Okay. Now there are two excited state. Of those two excited state, we are saying that E2 is metastable state. What is metastable state? Which has got long lifetime. I think already we have defined. Okay. But whereas this E3 excited state, it has got very less. Okay. It has got very less lifetime. Out of these three active energy levels we have taken, even is ground state, which has got unlimited lifetime. What do you mean by unlimited lifetime? As long as we don't supply any energy, atoms will try to stay in the ground state. And then we have two excited states, E2 and E3. Of these two excited states, we are saying that E2 is a metastable state, E3 is higher state. Now, whose lifetime is more? E2 lifetime is more. Okay, now, come back to first figure. Now I have more number of atoms in the ground state. Okay. When I don't supply any energy, there are more number of atoms in ground state. Now I started supplying energy. What is supplying energy? Let us suppose that I started supplying photons. Okay. Then what happens to these atoms? These atoms will absorb energy from these photons, and where they'll go, they'll get excited to E2, as well as they'll get excited to E3, because I'm not putting energy of photon to be E2 minus E1. I'm just randomly supplying energy. I'm just supplying randomly energy in the form of photon. These photons will have different energies, and based on which photon is going and falling on an atom, so there is a possibility of atoms going to E2 as well as E3. They'll get excited to E2 as well as E3. So after absorption, now I'll have some photons in E2 and I'll have some photons in E3. But atoms which have gone to E3, they'll try to come down to ground state fast. Whereas atoms which have gone to E2, they will not come down fast. Can you tell me why? Are you able to understand my question? Ma, first, where are our atoms in the ground state? I have supplied energy. And I have supplied energy, what these atoms in ground state will do, they'll get excited to E2 as well as E3. Now I am saying that atoms which have gone to E2, they'll not lose their energy and they'll come down to ground state fast. Whereas E3 atoms will release their energy faster than E2. Why? Because lifetime. Here, E3 lifetime is less. What do you mean by having less lifetime? It means that within short time, these atoms, they'll undergo spontaneous emission. Spontaneous emission means on their own, without any energy, they'll give their energy and they'll come down. So when these atoms within short time release their energy, when they get excited, some of the atoms they'll go to E2, also some of the atoms they'll go to E3. Are you able to understand? First atoms are in E1. After we supplied energy, atoms have gone to E2 as well as E3. But atoms which are in E2, they'll stay for more time. They won't come down fast. Why? Because its lifetime is more. But whereas E3, because its lifetime is very, very less, it is unstable state, these atoms, they will release energy and they will come down to E2 as well as E3. Now, after all this process, whose lifetime will be more? You will find that lifetime of E2 will be more. Why its lifetime is more? Because it has got long lifetime. What do you mean by long lifetime? Atoms which will come to it, they won't lose their energy, they'll stay for more time. But E3, because its lifetime is less, even if atoms come to E3, they'll come down fast releasing energy. So a stage will be released where this N2 or a population of metastable state will become more than N1. So this N2 is becoming more than N1. And this process is nothing but population inversion. What is population inversion? Making population of higher state more than lower state. Are we able to achieve now? Now E2 is higher state, E1 is lower state. So we are able to achieve population of higher state more than lower state, and this condition is nothing but population inversion. And one point what you have to understand here is always population inversion will be achieved in metastable state. This point if you want to write down in your books. So population inversion is always achieved in metastable state. Modern article. So population inversion is now, can you people tell me why always population inversion is achieved in metastable state? Yes. Why population inversion is achieved in metastable state? Disturbance, I'm getting disturbance. Learn Kushal. I'm not able to. Because yes, good. Because its lifetime is more. What do you mean by lifetime being more? It will retain atoms for more time. So that's why its population will be more. I hope you are able to understand what is population inversion. Right, students? Okay. So if you have taken this, then we'll go for one more definition. Then we can end up our session. So one more definition we'll take. So shall I go for next slide? Hmm. Okay, I'm going, right? So next definition is, this is a story all that I have discussed just now. Yeah, this is our definition, pumping. So what is pumping? So with all the discussion we have done now, can you tell me what is pumping? Now just look at this statement which I have given here. In order to get population inversion, okay, so what we have to do, we have to make atoms go to higher state. So we have to make atoms go to higher state. Now, in order to make these atoms go to higher state, I think we need to supply energy, right? Population inversion, how it is achieved? It is achieved only if atoms which are present in the ground state, they are made to go up. And how they are made to go up by supply energy. So this is our definition for pumping. So what is pumping here? Pumping is, it is the process of supplying suitable form of energy. So process of supplying suitable form of energy to a medium. Medium is material. In order to achieve population inversion is known as pumping, because we know that first lower state population will be more than higher state. But in order to make these atoms go up to metastable state, we need to supply energy. And this process of supplying energy in order to achieve population inversion is nothing but pumping. Okay. Now there are different pumping methods. Right, so there are different pumping methods. I'll note down, I'll just tell you quickly about those pumping methods. So is it clear what is pumping, students? Now coming to different pumping methods. I'll just discuss about just I'll give you 4 or 5 methods. First method is optical pumping. You note down these methods. And second one is electric discharge. And third one is atom-atom collision. And fourth one is direct conversion. And fifth one is chemical reactions. So these are some of the methods of pumping method. What is optical pumping? Optical pumping is the method where you are going to supply energy in the form of light. What do you mean by light? Light is nothing but photons. So what type of energy you are using in order to get population inversion? Energy, it is in the form of light photons. What is electric discharge? Where you are supplying your energy in the form of electrons. So here you are going to give discharge. What is electric discharge? Where you are going to supply accelerated electrons. You know anode and cathode, right? So electrode method, this is also called as electrode method. And using this method, first what we'll do, we'll get accelerated electrons. These electrons go and collide with atoms in the ground state. They'll give their energy to atoms in the ground state and they'll make them go up. And what is atom-atom collision? In this atom-atom collision, one excited atom goes and strikes atom in the ground state. Then there will be transfer of energy. Then the atom which has got energy, it will give its energy to another atom. Now this another atom goes to excited state. And what is direct conversion? Direct conversion is, this is just like our sublimation process. What is sublimation? Where you convert directly solid to gas state. Sublimation is the process where there is conversion of matter from solid to direct gas. What is solid? In solid, all the atoms are closely packed. It means that atoms won't move, they are without energy. But once you heat them, what happens to this solid material? It will get directly converted to gas, not to liquid, but directly to gas. But in gas, you know how the atoms are present. Atoms, they are present very loosely packed. They'll be moving in all possible directions. They'll be moving randomly. It means that atoms which are in the ground state, they are made to move with energy by converting them into gas state. So that process, it is called as direct conversion. And another method is chemical reactions. You know, I think you must have heard about exothermic reactions, endothermic reactions. So some chemical reactions need energy, whereas some reactions, they release energy. So suppose if you take two atoms in the ground state, when they are chemically combined, they'll give us a molecule, but that molecule, it will be in excited state. That process, it is called as chemical reactions. So using chemical reactions also, you can produce an atom or molecule with energy, which has got energy. So these are different pumping methods. And what you're going to observe here is different lasers are going to use different pumping methods. Like in ruby laser, we are going to use optical pumping. And we are going to discuss helium neon laser. In helium neon laser, we are going to make use of these two methods. One is electric discharge, and another one is atom-atom collision. There I'll tell you in detail about this optical as well as these other two methods. Okay, there you'll have clear understanding. So I hope what is pumping, students? Okay, what is the time now? So time is over. Shall we stop? So next class, I'm going to discuss about different laser systems. Okay. In that we are going to discuss about ruby laser and helium neon laser. Then applications will be there that I'll give you as assignment. You can finish applications. Okay. So mostly by Monday we are going to finish this module, and as I'm telling you, Tuesday and Wednesday we are going to discuss question bank. Okay, students. So shall we end our session here?
Okay, ma'am.
Yeah. So you people can leave.